Tonight we're going to be looking at the UniLab power unit 022.102. Commonly seen in schools, universities, colleges. UniLab, based in England, make a lot of scientific equipment for the education sector. And this particular one comes from a school that I work at, and it's here being repaired because I voluntarily do these things because I'm a really nice guy. I like to think so anyway. It's a great little power unit. It does 0 to 13 volts AC or DC, got a tap for both on it, at a rather whopping 8.5 amps, so it's a really good bit of kit. So they get used in the science labs, and over the years I've seen many of these thrown away due to the fact that they go wrong, but can we really blame them? They're made in England, so yeah. There's quite a common fault with these, which I'll demonstrate with this particular unit here. You select your main primary voltage using these little metal selectors. You'll see this one's missing. The first selector selects you allows you to go between 0 and 12 volts. You can add a denomination of 1 volt using the right selector if you wish to. So you can essentially have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 volts. You can probably see, as I said, one of them is missing. The primary selector is missing. Whereas this one isn't, and that is the main fault on these. So I'm going to flip this one around and show you exactly where the problem lies. So I've done this video kind of assuming that you've worked out how to take it apart. It's not particularly difficult. There's two brown side panels, one of which is here. Screw 1, screw 2, and then on the actual back panel of the unit there's a flathead screw there. Take those three out on each side and you've got access to it. It's a kind of simple, very modular system. So the voltage selectors are these long kind of U-shaped things which slide in from the common point into your relevant voltage that you wish to select on the front. They are made in, I'm sorry UniLab, they're just, I don't get the design. They are held into place, so located, by having what is actually a washer. I'll just try and zoom in on that. It's a washer soldered onto the end of the tab. Of course, this is subject to a lot of movement, and as we know, solder isn't really a reliable connection without a physical attachment as well. So for example, if you're joining two wires together, you twist them and then you solder them because you need a physical connection, and the solder just reinforces it. This is relying on the solder holding a washer onto the end of this selector. It's just not good. So in my wisdom, I've managed to develop a slightly better way of fixing these and repairing them. If you have these at school, I'd recommend you kind of catch the selectors when you can. I'm just going to set this down here for a moment. As you can see on the mat here, the guys in my school do save these as soon as they see them break. So I can now repair this using my new technique. A clue to what that is these tap and die set right here. Okay, so as I kind of mentioned, the original design on the voltage selectors for these isn't really that great. It's kind of soldered on, a washer's soldered onto the top to stop these falling out, and obviously that just fails because the solder connection is just weak. So what we're going to do is make a really good physical connection for these. We're going to get a tap and die set, which we use for putting a thread on a plain piece of metal. This is an M4 by 0.07, which is my tool of choice. It fits on here quite well, and what it will allow us to do is to actually tap a thread into this solid piece of metal, to which we can then attach a nut. We can put two of these on to create a locking nut system, which I'll show you shortly, which we can tighten up, and it will stop this from being pulled out because there'll be no solder holding a washer on, which will just fall out straight away. So to get the tap and die set working, we're just going to basically use a file. We just get ourselves a bit of a taper. This will allow the thread creation tool to actually locate on the solid piece of metal here. Files only work in the forward plane of direction, just FYI, so that's why I'm not doing back and forward. I'm just doing forward, forward, forward on like maybe a 45-degree slope to allow the tool to actually locate on there. So that's done. Normally I'd put this in a vise, but I'm just going to do it by hand so you can kind of see it because my vise is over this side of the workbench. So carefully we should be able to locate this tool onto here. I just can't do it without a vice. Okay, so what I've done is I've moved over to where the metal vice is. I've got the U-shaped voltage selector sitting face down in the vice, and I've put the tool here, pushing down, twisting with my hands, and what it's doing is cutting a thread into this piece of metal. Once that's done, we just untwist it. I've gone down about an inch. What I'll do is try and show you the results. Okay, so we're back over here and we've got our voltage selector now with added thread, and we've got two relevantly matching nuts. I think I said use an M4 thread. So what we're now going to do is relocate our voltage selector just through here. You may find that there's kind of solder stopping it going through. You can just clear that off with a nice hot soldering iron. See, now through here we've got the voltage selector with added thread. And what we're going to do is we're going to use a locking nut mechanism to make sure this never falls off again. We're going to put on our first nut and just do that by hand. And to be honest, you can spin this as far as you want it to go. I want to make sure that you can go as far as you want to go. You need to make sure that the selector obviously can come out far enough to select, because if you did that up too tight it would get stuck there. So I'm going to leave it where I've got it, which is about there. Now obviously as this gets pulled up, turned and moved, the one nut that we've put on may very well come off because it's being moved all the time, much like the solder joint was. So we're going to use a locking nut system, which is where we have one nut on there, and now we're going to put another nut exactly the same on behind it. I'm just going to locate it for a minute. Now what I'm going to do is tighten this nut up against the first nut. So I'm essentially going to be turning this one right to make it tighter and turning this one left, the initial nut left, to loosen it, so that they tighten up against each other, and that will then create a complete lock between the two, which means that they won't come undone. And I'm going to do that by using a 7mm socket, and I'd probably normally use a ring spanner on this, but I've got a pair of needle nose here and it's not exactly tight stuff, so I'm just going to tighten the bottom, making sure I don't turn them both, just get the bottom nut on the socket and the further nut on the needle nose. There we go. That's rock solid, that ain't going anywhere, and you can now select your voltage perfectly freely. 0 and 12, and there's no fear of that ever coming off again. Then obviously what we do is we put the piece of equipment back together. I won't show you this because I didn't show you me it taken apart. I have pat testing here, so what I tend to do is pat test them because I've taken them apart. Obviously the most important thing is really physically checking you haven't damaged the cable. I mean, as you can see here, the supply cable throughout this entire process has been touching the sharp metal edges of this unit, because obviously I've been busy trying to explain it and not concentrate on what I'm doing. So I'm going to make extra sure that those internal cables aren't damaged, and I'm going to check all the cable along the way as well. I always check the mains plugs in these. A lot of them are moulded, some of the older ones weren't, so they can be opened. Just open them, check them if you're competent to do so. Obviously if you're competent enough to do that, you shouldn't be doing this unless you're competent enough to do that. Open them, check them. I would say these ones that go out around in schools, about 50% of the ones I fix tend to have either terrible wiring in the mains plug, or they've developed a fault along the way, usually because obviously the kids plugged them in and pulled the cables and whatnot. I've already checked this one, I know it's fine, rewired it. I also then run them through my pat tester, and I'd encourage you to run them through a pat tester as well if you're working in a school, because obviously they are kind of very high risk appliance because kids are touching them every day, so you don't want any accidents happening. Obviously, as you can probably tell, I'm very competent in what I'm doing, and I've got a whole array of electrical qualifications, so no problem me doing it. And as I say, I'll run it through the pat tester in a minute. And that's it. So if in doubt, don't throw these away. They can be fixed. I can fix them for you if you're not competent to do so yourself. Obviously, I'd never suggest that anyone who's not competent ever fixes these, especially because they tend to be in use in educational establishments. You can contact me for either more advice, or if you want me to do a job for you, I can have a look into that. There's a number of other common faults that these units get, not just the selectors failing. They do sometimes give out really dodgy voltages, which isn't great. The breakers occasionally fail in them. They've got an integrated circuit breaker. Apart from that, they're pretty rock solid items, but I can fix pretty much everything that goes wrong with these. So I'll do another video on the dodgy voltage outputs at some point soon, but any other questions, just hit me up in the comments. Thanks for taking the time, and I hope I've helped some of you.